Hello and welcome to the Capgemini Super Techies Show Season 2. This is the first reality TV series where IT professionals get to exhibit their tech talent to the world. This year, of course, we've gone bigger, it's tougher now, and of course it's international. We've got global challenges from global companies and teams from both India and North America competing for the ultimate prize, 15 lakh rupees up for grabs. The way this show is designed is that 27 teams are selected after rigorous elimination. They go into 9 league rounds and 3 semi-finalists from each of those league rounds battle it out, and 3 teams eventually make it to our mega final. Every week, a CXO from a leading global or Indian company presents a challenge to our teams. Last week, we had Team Execute from North America win the Marico Challenge and take the second spot in our second semi-final. So 1 more spot up for grabs in that knockout round. So what's the challenge before our teams today? We call our first round the challenge.
Welcome to Seattle, Washington. Located in the Pacific Northwest region of the United States, Seattle features beautiful landscape, a rich cultural scene, and of course, a treasure trove of incredible coffee shops. In the early 90s, at the height of the dot-com era, Seattle was a hive of activity for new startups trying to make it big. But Seattle remains another technology epicenter in North America. Some of the biggest, most well-established brands in IT are here, including Amazon Web Services. As a global leader in the technology industry, AWS has become one of the first names you think of when it comes to the cloud. Today, our Super Techies are going to receive their challenge from AWS. But before we hear what's in store for the teams, let's hear from Amazon Web Services. Amazon Web Services is a leading provider of highly reliable, scalable, low-cost infrastructure platform in the cloud. They power hundreds of thousands of enterprises, governments, and startup businesses in 190 countries around the world.
Amazon Web Services started in 2006. What we learned was running a highly scalable web application like Amazon.com allowed us to become experts in running highly scalable data center infrastructure as well as web services that allows us to now publish that out to a new customer segment of developers and enterprises.
As the Managing Director of AWS for Asia Pacific, Shane Owenby leads the customer-facing teams that help organizations across the region learn about and implement cloud computing. Shane has been responsible for building sales, marketing, and evangelism teams to drive the revenue growth of AWS in Asia Pacific.
We know that the information around the world is going digital and it's exploding with the internet from a reach perspective. And so we want to be able to understand how customers and how cloud computing users can use this technology to get their information out to a much wider audience at a very low price. And so the challenge is really about how to scale a large application usage at a very low price that scales up and scales down as usage increases and decreases. Hello contestants. I'd like to issue you the challenge of having to build a scalable web application that's going to scale to millions of users down to hundreds of users for stored video content as well as live video content. I look forward to your response and understanding how not only it's going to scale architecturally and technically, but also how that affects the cost. As in these days and age, we need to look at not only technical challenges for super techies, but also for cost.
That's the challenge on this week's League episode. Let's find out who are our 3 super techie teams that are going to present to our jury. Team 1 from India are the Noons. Welcome to the show. We've got Hack Studio from North America. Hi guys, thanks for coming all the way. And our third team today, also from India, are the Pathbreakers. Welcome. Let's also introduce you to the man who's designed today's challenge. Shane Owenby is MD for Amazon Web Services Asia Pacific. Shane, thanks for joining us on the show and making a great challenge for our teams.
My pleasure.
Also joining him on the jury are Professor Subhash Bhatnagar, who's an adjunct professor at the Indian Institute of Management at Ahmedabad. Thanks for joining us. And we've also got Harish Rao, who's Senior VP and CTO for Global Infrastructure Services at Capgemini. Harish, thanks so much for joining us on the show.
Pleasure.
The 3 teams also had a mentor who helped groom them through the process of preparing their presentations to make to the jury. We have him here. Venkat Iyer is the practice lead for Business Information Management at Capgemini. Venkat, thanks so much for joining us on the show. What was the experience like in mentoring these three teams?
Actually, Abhimanyu, I was here in season 1 as well, so this is like a deja vu for me. I had a lot of fun in mentoring all the three teams. I would say that the challenge, although it looks very simple, has a lot of architecture and solution behind it, which makes it a little bit complex, and you can really come up with multiple ways of approaching it, and I'm pretty glad that all the three teams approached it a little bit differently and have come up with good solutions that you're going to see today.
Right. Thanks, Venkat. So our mentor is quite optimistic that our teams are going to wow the judges. We'll have to see if the jury agrees with him. We're going to get the ball rolling on this show very quickly, but before that, we'll take a short break. Do stay tuned to the Capgemini Super Techies Show Season 2.
Looking at the problem, since it's based on Amazon, we're looking at how to leverage Amazon services to the best to build our solution in the optimum cost.
I wanted to keep this to be as innovative as possible, really want to think outside the box, but always trying to plan ahead as well. So having the right frame of mind along those lines.
Welcome back. You're still watching the Capgemini Super Techies Show Season 2. In the first segment, we introduced our teams and the jury, and also the problem statement given by Shane Owenby of Amazon Web Services, basically to design a service or a system that would enable content distribution of live streaming of events or even pre-recorded content, but to be accessed by all kinds of different mobile devices. So how do our teams respond to that challenge? We call this round the solution. So without any further ado, our first team, Noons, whenever you're ready, you can address the jury. You have 2 minutes.
So the solution that we are providing for the Amazon Web Service Challenge is creating a platform, which is a highly scalable platform, and build over the Amazon Web Services as a base. This platform has a responsive UI to the users, as it takes into consideration the resolution of various devices from which the users are going to pitch in and try to view the videos.
To take you through the architecture of how we went about building this. What we have at the base is a .NET web application which we deployed to Amazon's Elastic Beanstalk, which allows it to scale as the load on the servers grows. The more the users, the greater this will be. It will bring in instances on the fly and make it work. Users can use this web application to upload video, and this is what forms the pre-stored content part of the problem. The pre-stored content is then processed through an Elastic transcoder, giving us various process data to multiple different formats. In the case of a live event, when a broadcaster comes and creates an event, at the duration of the event, an Elastic EC2 instance is created which runs Flash Media Server. The live feed is provided to this server, and at real time, you are able to get both HLS as well as RTMP, that is the formats that are supported by iOS as well as Android and other web applications. Backing this whole infrastructure and making it work is our machine intelligence that observes all the user data. The user demographics are logged and processed later. What we use is Hadoop to process this data. We use collaborative filtering to come up with the final responses to the users.
And to monetize the product, the platform, we are proposing 3 products. One is the web app server, one is software to television or TV channels, and the third is software to film makers.
Shane, what did you think of their solution and any questions for them?
Yeah, it's very interesting. I think you've taken to heart the challenge. You've understood the issues at scale. One of the areas that I think I'd like to hear a bit more about is how you've thought about not only scaling the users up and down as they come to the site, but also the cost implications of that. Can you talk a little bit more about that?
So to keep this at a bare minimal cost, what we are doing is we are analyzing all the user statistics that we gather. On basis of this, we are coming up with a probability distribution of where users would be viewing a particular video. What this allows us to do is target specific locations where we know users would be viewing this data and give them a very high quality of service. So where there are users, there we go for a high cost but high availability solution, and where there are lesser users, videos that are not watched are taken down and moved into a service like S3, which works as the archive and allows us to keep cost to bare minimal.
You have a number of comprehensive features within what you're proposing. Have you considered how this complex configuration is going to be defined and maintained and reconfigured as it develops further, and some way of managing it? Do you have a management interface to it?
The user expectations these days change from day to day, depending on what new features come in, and the web itself is evolving at a very fast pace. And the tools that we have used allow us to develop at a very fast pace. We could put out the basic applications over here within a week's time. So you can see that a dedicated team striving towards making this application better would be able to give a very good user interface to users over here.
Right, thank you, Team Noons, for answering the questions put by our jury. Our next team to make the presentation, our Hack Studio from North America. Gentlemen, whenever you're ready, to the judges.
The first component is the mobile peer-to-peer, which is a network that connects or interconnects all the mobile devices that are within a proximity. Using the second component to our approach is the BitTorrent protocol, which basically breaks the information or the videos into smaller bits of information that are very easy to transport between all the mobile devices connected in the mobile peer-to-peer, and then reconstruct them at the application level where the user can view them and enjoy watching the video. The benefits of our approach are basically that we are crowdsourcing all the server log to the users. We are able to use different connectivity methods. For example, if all the mobile devices are within this room and they are using the Bluetooth communication, then you don't even have to use your data plan if you are afraid to run out.
When it came to distribution, we wanted to set it up as two settings for the app. First one would be a trial run, basically, where people can pretty much set it up for about a month, get a feel for it, get a taste for what it has to offer. Then they can upgrade to the Pro version. With the Pro version, they get more access to more features from a global scale, having more content accessible to them. They can tailor-make a subscription or at least a year-long setup for them as well for membership. It is with that they can also get through the other incentives that can be provided depending on how much they use it and how much time they put into it and how many benefits we can provide them with based on their usage.
Shane, they said the word BitTorrent in a presentation about content. It's almost like a bad word, especially for traditional industry. So pretty disruptive that way?
That's an interesting approach to take, but one of the key parts of the challenge was also global scale, and you've made a big assumption around proximity. So what I'd like to understand is a key part of the challenge, how you're going to serve the global users when we didn't give you a number of those, meaning it can scale from tens to millions. I didn't hear in your explanation a way that you covering the scale of those users around the globe.
This application is built to be able to be used by millions of users as well as few users if you have in the room. And the other thing that we are plan to use is we are going to fall back on the traditional approach by using Amazon Web Services that are pretty much like the best cloud solution we have right now, and that's deployed in different places in the world, and that's how we're going to solve this scalability issue.
If Shane was to actually think about trying out your solution, I would like you to suggest to him what else do they need to do, what stages do they need to go through before they can actually deploy the solution, because clearly in a week you could not have thought about every issue and everything. You've given a basic solution, so could you tell him the next steps?
Well, basically what we're going to do is we're going to follow the software development lifecycle. So this is clearly in the design phase, and then the next thing we will do is basically to refine the requirements with Amazon, and then from there we can come up with a development plan and a project plan that we can implement, and then do some testing as well and push it to the end users.
Well, thank you very much, Hack Studio. That was a fairly interesting solution to the problem thrown by Shane at Amazon Web Services. We have one more team yet to present, but we're going to do that after a very short break. This looks like it's heating up, so don't go anywhere. Keep watching the Capgemini Super Techies Show Season 2.
It was quite interesting. I mean, we get in-depth information about the problem that we got it out. We get some overview how we should proceed about, and the key result that should help us win the challenge.
Welcome back. You're still watching the Capgemini Super Techies Show Season 2. This is the hunt for the top IT professionals. We've had two teams, Noons and Hack Studio, make their presentations to the judges on this very interesting challenge being thrown. Our final team today are the Pathbreakers, and we're going to get to it straight away. Whenever you're ready, gentlemen, to the jury.
So our solution takes into consideration the entire chain of events in the media streaming process, right from content ingestion to content creation and to distribution and to deliver the ultimate end user experience.
The core principles of our architecture are cloud-based storage, which helps user with a multiple access to the end user to upload their videos globally and at a faster rate. Once the video is stored, whether it is a live video or a video on demand, it needs to be processed. So we provide a state-of-art processing engine that helps us with a very high throughput of processing of these video streams, all based service-based provisions we have provided. So we provide a SOA architecture where a bus can orchestrate through these services. And then once these media streams are processed, we store them in our, again, cloud-based grid storage system. And then we provide a state-of-art querying engine to query these stored media contents for availability to the end users. We make it available to our CDNs. We call it mobile CDNs than the traditional CDNs. And with this, we try to reduce the middle mile distance between an end user and the origin of the content. And with distributing it across the mobile content delivery network, we try to achieve quality of service through 4 matrices that we provide: availability of streams, startup time of the streams, frequency of interruption, and the bandwidth available for the quality of streams. So these are our 4 quality measurements that we provide.
So coming to the USP of our solution, which we are referring as a mobile content distribution network, what we basically mean by content distribution network is to have replicated data across the globe, across different geographies, and the data sets are these replicated servers. We call them as edge servers, which will cache the data which is intended to serve the live audience. So anybody who's looking for a solution need not go over the internet to fetch the data. These data are stored in the edge servers, and these edge servers get the data from the parent servers, which are where the content is getting ingested.
Shane, Pathbreakers suggest you get into the CDN business as well.
Yeah, luckily we are in the CDN business, which is good. They talked a little bit more about the mobile CDN, but one of the things I was curious about with Pathbreakers is you talked a lot about, part of the challenge was around highly scalable infrastructure, but also fault tolerance. So I'd like to hear more about your failure rates, failure modes, and how you're thinking of high scalability and fault tolerance.
So for failure modes, we assume that everything in our network can fail, starting from the cluster to the machine, to the storage and to the service that does the processing. So that's why so we have tried to design it in a self-healing way. So for example, any S server fails, so our dynamic DNS, which again comes from Amazon CloudFront, we try to incorporate it with the CloudFront, with the CDNs, instead of reinventing the wheel.
If we look at the solution, it sounds like a traditional solution to many of these types of content distribution, etc. What are the features in the solution that makes it extraordinarily scalable and maintain the low to high the low costs of operation and scaling up in a cost-effective way?
There are multiple things that makes it unique. First of example, we provide for the scaling up. We provide an inbuilt elastic clustering that comes from Amazon again, where if say I make a video today and want to upload it out, nobody might be seeing it out today, and there will be just one user using it out, and the resources will be used. I mean, very limited resources will be used. Or for example, for event of an Olympics, this system has to scale up only when Olympics is happening. You don't have to pre-build the system, and these resources goes down even after Olympics event. So what we do is, whenever the demand comes in, our cluster automatically rebuilds a second resource when your 70% or 60% of load limit has reached, and you plug in another resource for scaling up. And same way it can go down for scaling down as well. Like say for example, now the Kolawari videos view rate has gone down. So you just scale it down to the resource.
Pathbreakers, thanks so much for taking the time out to answer our jury members' queries. We've got our 3 teams done with their presentations, and the grilling by the jury is over as well. It's time now to find out how they scored. This round is called the verdict. Okay, the three teams are judged on three parameters to come up with their final scores. First, we have problem comprehension that gets 20% weightage. Then we have the quality of the solution itself, which has the highest weightage at 60%, and the remainder 20% is on the quality of the presentation itself. So I'm going to request the members of our jury to log into their terminals and score our three Super Techie teams on those parameters. But in the meantime, just to get a sense of what our audience thought went on over here, I'm going to ask them to vote as well, and your time to vote starts now. Okay, time's up. Let's have a look at how the audience voted. Remember, this doesn't actually count towards the final score, but it's just a barometer of what our studio audience felt went on. And the audience scores are as follows. More than 60% of the audience, in fact, thinks that Team C, the Pathbreakers, have won it. But let's see the score that really matters. The final verdict of the jury is as follows. And indeed, the jury seemed to differ from the audience because according to them, our winning team today are the brother-sister combination from Mumbai, Team Noons. Congratulations, guys. Shane, what do you think of the winning team's solution? Any scope to actually explore implementing it? Maybe you're just even getting them to brainstorm with you at Amazon?
Yeah, one of the interesting things about cloud computing, which this team was able to showcase, is that you can actually prototype the solution. So not only do they have wireframes and theoreticals, but they actually went and put it into practice and tried it out. I think that's what differentiated their solution and proposal from some of the others.
Thank you, Shane, for designing the challenge today and being on the jury. Thank you to our other judges as well. So there you have it. Team Noons picks up the final spot in our second knockout round, the second semi-final, where they will join the Tequila Shots and Team Execute from North America for a place in the grand final. We hope you enjoyed watching this episode of the Capgemini Super Techies Show Season 2. Do tune in next week as well.